ready to start lesson 3 in our heritage studies today. This was a map I was actually supposed to show you, I think yesterday or maybe the day before. Maybe I may have shown it to you on our very first lesson. Just an old map, one of the very first maps it looks like. All right, so today, this is, let's see, we worked with these yesterday. Let's see, I gotta turn these around just so. There we are. Now, let's go ahead and get our our reader out. We're going to turn to page 5 in your reader where it says globes. Now, I'm going to be reading to you in here. We're going to be talking about the different kinds of maps, globes, and that kind of thing. So, if you were to take an orange or a tennis ball or anything like that and flatten it, what's going to happen to it? Well, of course, the orange is going to smash, but let's just say you peeled it whole and the orange was not inside of it. You just had the whole peeling. Anyway, if you smashed it or you smashed the tennis ball, it's going to crack and break on the sides, isn't it? Okay. So I want you to listen and follow along starting on page 5. I'm going to read it just a little bit, and I want you to listen for why is it that a globe, and I have a globe here behind me, why is it that a globe represents the earth the best, and what kind of map shows more details? Okay, so we're listening for why does a globe represent the earth the best, and what kind of map shows the most details? I want you to listen for that as we read, okay? All right, so let's start reading on page 5. Now, you got to follow along with me, okay? All right, the first geographer was a Greek mathematician named Eratosthenes. At a time when most scientists believed the world was flat, Eratosthenes believed the world was a sphere. Look at the old map made by Eratosthenes. It's the one at the very bottom. I think it's the one that I showed you before. What do you know about the world that Eratosthenes did not know? Before spacecraft could take pictures of the earth, people discovered land shapes by sailing around them. Many explorers helped add to our knowledge of the world's shape. Some sailed around the tip of Africa, some sailed to the New World, and some sailed around South America. Since the earth is a sphere, a globe represents the earth most correctly. One of the first globes ever made was the handiwork of Martin Baum of Germany in 1492. Globes have been made in many different sizes. In 1999, one particular globe called Eartha was added to the Guinness Book of World Records. The book's editors named Eartha as the world's largest rotating globe. It measures 41.5 feet in diameter and fills a 3-story room in Yarmouth, Maine. There's a picture right there at the top of page 5, and it's a picture of Eartha. So, why is it that a globe represents the earth the best? Because it's the same shape. The earth is a sphere, and a globe is a sphere, so duh, it represents it better. All right, let's read then about flat maps on page 6. Now remember, we're still looking to find the name of the map that shows the most details. Have you ever taken a ball or an orange peel and flattened it? What happens to the sphere shape when you press on it? The same problem happens when you flatten the sphere shape of the earth. Many areas on a flat map appear to be different shape or size than they actually are. These areas are distortions, and they don't accurately show the earth as it really is. It's impossible to take information from a sphere and make a flat map from it without cutting or stretching the original shape. Cartographers have been struggling with this problem for centuries. A flat map may not represent the Earth's shape or surface as accurately as a globe does. I have to answer my call. A flat map may not represent the Earth's shape or surface as accurately as a globe does, but flat maps can show more details. Imagine how large a globe would have to be to show all the streets in your state. Flat maps are also easy to carry and to store. Now let's look at where it says map projections. Any method that cartographers use to show the Earth's round surface on a flat map is called a map projection. Each map projection has distortions. Now remember, distortions, that's where when you take a flat map and you're curving it, or a curved map and you flatten it, and things aren't going to be exactly as they're supposed to be, that's called a distortion. So map projections have distortions on them. Okay, one of the most common projections is the Mercator projection. It correctly shows land along the equator. However, the areas at the top and the bottom of the map are distorted or stretched. On this map, Greenland appears to be larger than South America, but actually South America is 8 times bigger than Greenland. So if you'll look at that map there at the top where it says Mercator projection, okay, now you see Greenland is, let's see, where is Greenland? Okay, yeah, you see how small South America looks? But look at the very top, right up above the United States. That's Greenland. Greenland is not bigger than South America, but on the Mercator projection, it may be right along the equator, but everything else on the top and bottom is not right. So there you go. All right, let us then turn the page. Now, another common projection is goods interrupted projection. This projection cuts and flattens the earth like an orange peel. There's a picture of a boy that's got an orange peel up there, what he's done. The map remains in one piece, but the earth is interrupted with gaps or cuts. The shapes and sizes of land masses are fairly accurate, but this projection distorts distances and all north to south directions. So, yeah, not all of them can be exactly right. They're just projections. They're just, you know, supposed to look like it. All right, so we know that flat maps can show lots more detail than a globe. A globe can't, because here we're looking at, this is Saudi Arabia, this is India, so this is all Asia right here. This, I guess, thing down here, this would be Australia. Over here, you've got Africa. So now let's look at this picture here. Now this is showing the earth as if you're going to take it apart, kind of like he did that orange peel, tearing it apart in these little projection things so that you could lay it out flat. And the only way you can lay it out flat, you know, and curve it around where it fits just right is if you put those little cuts and stuff in it right there. So that's the only thing that can be done there. Okay, now, there we go. I think I was supposed to show you. Yeah. This is our mini globe. This is where it's cut out like an orange peel, kind of like the one that we used yesterday. All right, so let us then go ahead and, well, first of all, I wanted to ask you something very important about, well, actually, let's not forget our very first geographer, which was a great mathematician. His name was Eratosthenes. Kind of a weird name. Eratosthenes. There's his map down at the bottom of page 5. That's his map. Now, in 250 BC, Eratosthenes observed that a post in Alexandria, Egypt, cast a shadow at noon, but a post the same size in Syene, a town south of Alexandria, did not cast a shadow. What do you think this meant to Eratosthenes? Well, he thought the earth must be curved. He made some calculations and determined that the distance around the earth was about 25,000 miles. He was only 140 miles off on his answer. Before this, nobody had ever proven or measured about the earth being round. Everybody thought it was flat. So the map on page 5, what is it that we know now that he did not know then? I think we've already talked about this. Well, he thought in his day that that was the only land mass. He didn't know, and nobody else knew, because not everything had been explored at that point. A lot of stuff had not been explored. And so he didn't know that there were other land masses there. How did people find places and map things back in those days? They didn't have, you know, helicopters or airplanes or, you know, things to go way up. They sailed around it. That's what they did. All right, so I want to make sure that you remember what a distortion is. A distortion is basically it's an error in a map is kind of what it is. It's a part of a map that's not really an error, but it's distorted from the actual thing of what it's trying to show. Also, I want you to make sure that you keep in mind Good's interrupted projection and the Mercator projection map, okay? Make sure you do that. All right, so today, let's see what we have today. Okay, we have page 5 in our work text. So can you get page 5 out? I keep forgetting my work text. My new work text is not a book. It's actually on here. So I don't know how to get on here without I don't know how I'm going to do this. All right, let's look at page 5 in your work text. Okay, what it is it is a study. It's a study guide page, I believe. Okay, so what I'm going to have you do is I'm going to have you pause this, okay, because I'm going to have to change my camera around. Once we, I want you to work on the work text page on the study guide page, and you can use your book. When you're finished with the study guide page, turn this back on because we're going to go over the answers because then you have a quiz. Okay? All right, go ahead and work on that. Okay, so I have to change my camera because I have to get it off of my, well, let's see. Here we go. All right, so I'm hoping that you're done with your study guide page. All right, if you're not finished with the study guide, I want you to pause it and I want you to finish it. When you are done, you can turn it back on and we'll go over the answers. Okay, so if you have it on, I'm assuming you're done. Now, you need to use a different color. You need to use a pen. If you have a red pen, that'd be great. If not, just a different color pen because if you miss it, I want you to put an X beside it, okay? All right. Number 1 is D. Number 2 is B. Number 3 is G. Number 4 is A. Number 5 is C. Number 6 is E. Number 7 is F. Okay, on part B, number 8, a non-Christian geographer may say, the first one, that our natural resources took millions of years to form, and the last one, that many wonders on earth happened by chance. So those two you should have filled in. Number 9, you should have the last two filled in. I'm going to sneeze. A Christian geographer may say that we need to consider that what the Bible says while we study nature, and that God created resources for our enjoyment and to be used wisely. It's the last two on that one. Okay. Now, if you missed any of those, just kind of put a little X or something, just so I'll know. Okay. Letter C. Okay. Write true if it's true, and then if it's false, you have to mark out the incorrect part and write the correct word. Number 10 is true. Number 11, you should have marked out flat map, and you should have written globe. Okay, number 12 is true. All right. Now on D. All right, now on number 13, that map is the Mercator projection. The Mercator projection is the one that shows along the equator is correct, and everything else is a little distorted. Number 14 is Good's interrupted projection because it shows pretty accurate shapes of the land masses, but you can't really measure distances on that map. Okay? All right, good deal. All right, now what we're going to do is I'm going to have to find the quizzes. I did not have it pulled up. So let me see if I can find the quizzes. Here they are. Okay. Let's see, so we're going to take quiz 1A. Now I need you to close your books. Close everything, okay? All right, so what I'm going to do is I'm going to change my camera around again, and I'm going to put quiz 1A on the screen, okay? At the top of your paper, get a piece of paper, and at the top I want you to write quiz 1A and put the date. That'll tell me what it is and all that, because it's not a piece of paper printed out. It's just one I want you to take on here, okay? All right. Actually, I'm wondering if maybe we should just print it out. Let's go ahead and print it out. I'll have a note here, and I'll ask your Nana if she would print out the quiz. I'll just see if she can do that, and then she can just give it to you, and you can take the quiz. Make sure when you take the quiz that you put everything away, okay? I do need to have a picture though of your study guide page so that I can take a grade on that. Now, when you take your quiz, I don't need a picture of it because we're going to go over it tomorrow in our next lesson, okay? All right, so I'm assuming then that is all. If you have any questions, let me know. And otherwise, go ahead and take your quiz 1A.